Building on ERDs, we delve into schemas, a database's blueprint. Schemas reveal how data points relate. In our next video, we demystify schemas, connecting facts to dimensions, numbers to context. With a dummy table as our guide, we'll unravel the structure of data warehouses. Join Vishwa as we dive deeper into the world where data becomes meaningful. Get ready to understand how your data is organized. Let's begin.
Welcome everyone. In this video, we'll try to understand what is schema. So whenever we talk about the relational database management system, the first thing that pops up is schema. What is schema? Schema is nothing but it's just a logical view of your entire data sets, how the data is arranged, how the data is related to each other, how the data is structured in the form of the different tables, how the tables are related to the one form to the another. So schemas are very core to any kind of relational databases. It helps you to at one go defines what all tables that you're going to create in your database. At another layer, it helps you to define that how the tables are kind of connected to each other. And thirdly, what are the properties of each of these tables? So that's what a schema is. Now, let's say to understand a database or a data warehouse from the perspective of a data scientist. Most of the time in the data warehouse, almost all your data will be present in the form of the flat files or a big table with so many columns. Now, at any given moment of time, as a data scientist or as an analyst, we would like to focus on one target and get some insightful meaning out of it. So, any table, any big table that you see in a data warehouse or a database, they the columns that it contains you can categorize into two different categories. The first one is called as fact. Fact means any numerical values that you can measure, the metrics, the values, say for example, salary, say for example, revenue, say for example, total sales. These are the metrics that you would like to go and measure. So normally you go and measure the metrics to see the trends, how your business is doing, how it has been doing time over time, right? So some of times you might be interested in these numbers and manipulating them and understanding them. So when you go and take a part of your table, the original flat table, and take out those columns which have the numerical values, which has metrics that you would like to measure, the table that is formed is called as a fact table. When you take out the facts from the original source table and you look for those columns for which these facts has been defined, say for example if I'm talking about fact called salary, so whose salary is it? It will be a salary of a employee. So the employee here is called as a dimensions. So dimensions are those attributes that you are interested in for which the matrix has been defined. So the fact are always defined for certain dimensions. So sometimes as a data scientist, I'm more interested in understanding the dimensions for which the matrix has to be calculated. So when you take out the dimensions and put it separately into a table, that table falls under the category of dimensions table. We'll be taking a hands-on approach and see that what is the difference between a fact table and dimension table and how these two tables are related to each other with the help of foreign key.
If you've made it this far in the video, give us a like, a share, subscribe, hit the bell icon, tell us what you want to learn next in the comments, and then wait. Or skip the wait and become a data scientist in just 12 months with the Executive PG program in Data Science from IIIT Bangalore, powered by upGrad in collaboration with experts from Meta, Myntra, and LinkedIn. Over 20,000 working professionals from over 65 batches have already done this course. Now, back to the video.
In this video demonstration, we'll try to see that what is a fact table, what is a dimension table, and how in the real world we kind of create a fact and a dimension table from the source table. Most of the time when we work in the data warehouse world, the source table that we have in hand will have many columns. Say for example, if you're working for a company like a e-commerce, let's say that you're working for an e-commerce firm. So normally in the e-commerce firm, you will have to deal with the different entities like orders, users, sale volume, profit, items. What happens is that in order to make sure that the queries doesn't take much time and we are working on a flat file, we tend to store data in the denormalized format. It's like one big file with many columns. So what you see on the screen right now, right? What you see on the screen right now is an example, is a demonstration of this, right? We have the information around the orders, we have the information related to the users, we also have the sales related information, and then we have uh, item related information also here. Now, this single table might have too much of information to hold on, and sometime when we have to take some kind of business critical decisions, we need some focus. The focus either around the numbers, the metrics, which we go and call it as a fact, or the entities for which these numbers has been decided, which is called as a dimension. So as we know, this whole table comprises of two different stuff. One of that is called as a fact. As we know about the fact is nothing but the numbers, the values. Say for example, in this case, the sale amount will be the fact, the sale profit could be the fact, the item price could be a fact. So these are the examples of fact. On the other hand, the entities for which these numbers are defined, say for example, the username. This username is an example of the dimension, right? Say for example, the order details. The order details is an example of a dimension for which we'll be calculating the sale amount, the sale profit. So when we try to analyze this big data, this whole table which comprises of multiple columns might not give us very insightful information. So what we tend to do is that we try to break this table into two tables. We try to take the source table and try to break them into the multiple tables. Let's try to do that. So what we do is that out of this table, first of all, let's try to create a fact table out of it. So the fact table contains only the numerical values as well the primary key or the identifiers of the different dimensions. So in the center what we can do, and in the center what we can build right now here is we can have the information like order underscore id. We could have the information around something called as a user underscore id. We can have the information of something called as the sale underscore id. We could have some information around item underscore id, right? And then we have the information around sale amount, sale underscore amount. And then we have the information around, say, called item sale profit. And we can also have something called as item price. Let's put it here itself, item underscore price. So what you see here is that out of all the different columns that we have on the sales table, we have tried to pick all the columns which are numerical. What are those? Item price is that numerical column. Sales amount is that numerical column. Sales profit is that numerical column. And along with it, the identifier of the different other important entities that we have in the system, which we go and call it as a dimension. So one of my dimension is that order. For order, I would like to know the sale volume. Other dimension could be the users. For the user, I would like to know that how much he has bought. Another could be the sale entity itself, right? So what we have in the center right now is called as the fact table. This will be the general schema of the fact table. And then to this fact table, multiple dimensions tables will be attached. Say for example, for the order, there will be another table here, which will be called as order table, which will have something called as order underscore id, order underscore details. For user ID, we could have something called as user underscore ID, and then you will have the user underscore name and user underscore address. So this will be the another table. For the sale ID, we could have an identifier where we have the sale underscore ID, sale underscore details. For item, again, we could have another table here. We'll have the item underscore ID, item underscore name, and item underscore details. So what we see here, in the center, we have the fact table. And each fact table is related to the multiple dimensional tables in different dimensions. And each of them are related with the help of primary key and the foreign key. Say for example, if I talk about the users table here, the user ID is the primary key which is acted like a foreign key in the fact table. So what we come up here is that in the center, I have one and only one fact table, and then we have the multiple dimensions tables which are attached to the same fact table, which is related with the help of a foreign key. So the structure we get is more of like a star structure, in which we have at the center the fact table, and at all the corners I have the multiple dimensions, and that's why the schema that comes out of by breaking this denormalize a table with multiple columns into the smaller tables into the fact and dimension, this turns out to be called as the star schema. The schema that we achieve as a result of it is called as star schema. So this star schema is very common when it comes about analyzing the data, making the meaning out of the data from the data which is there in the data warehouse for taking the insightful informations.
Concluding our discussion on schemas, it's clear that the way we organize data will continue to evolve. आगे की सोचो with upGrad and stay at the forefront of data organization and analysis, ready for future challenges.